Welcome to my class. This is what I taught young students learning to code at Stanford Splash Initiative, which was just the weekend of April 9th to 10th, and we were teaching really young people 7 through 12 how to code. And here, this is the data structure part. So when we talk about data structure, this class can be very useful for you too, if you're just busy. So when we talk about data structure, there are a few basic data types you want to know if you're learning to code. One is definitely text. Text is very important. In computer science, it's also known as strings. It just comes in something like, the double quote, say my name, you, or single quotes. And this comes in very handy later, and we'll see why much later in the course. So I can store all of these in a variable. So x equals to, or better yet, my name equals to you. And some languages end with a semicolon. And then when I start storing this string in this variable, I can start to do something to the variable. I can say print my name, and the computer will return. That means the computer will give you some value in your terminal or browser, and it will just say you, and actually without the quotes usually. So that's really handy. And a lot of times computers really is about kind of references to its data storage. So somewhere on the computer, either in your hard drive or in the cloud, the computer managed to store data and keep a reference to the data, so it knows where to look for it. And it's kind of like Google knows where to help you find the correct website. Sometimes it keeps a reference called the hash ID. So it said, go to blah, 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 blah slot of my data storage and retrieve this information. So, excellent. So what are some of the other basic data types you want to know? Definitely numbers. So you can say x equals to 12. And this is what our students are familiar with, right? So x plus 5 equals to 10. And then what does x equal to, right? You solve that, except, this would be incorrect computer statement, right? So we will say something like this, x equals to 10 minus 5. And then when you print out x in this case, so I reassigned. First I assigned it to 12, then I assigned it to 10 minus 5. When you print out x, the computer will return something like 5. And that's an integer. So integers are stored differently from decimals. Sometimes decimals are stored in computers as float or double. Let's not worry too much about that now because we're focused on the basics. And basically, what we want to do is revisit this concept later. And if you're a professional in finance, this started to become very important for you, float and double. The way decimals are represented in computer science has to do with how the storage was designed initially. And when you're in banking, that becomes very, very important to get that pennies and fraction of the penny right. Because when we, as you can imagine, in stock market, the speed matters and the accuracy matters. So you will hear a concept where it says, rather than 15.69 cents, it may be stored like something like var, int. My int, so for simplicity's sake, is 15, and then like var, my decimal is 69. And then some algorithm will be put in place to put these two numbers together, and it will be formatted maybe as a string, and then converted to a float later. So there's quite a bit of algorithm that would go on about the pennies and fractions of pennies in financial industry and banking. So you may want to look at our full course or email us to get the episode on how to deal with numbers in banking.